Hello everyone, in the last video on designing modern roundabouts, we discussed the geometric design of entry approaches of single lane roundabouts located in low speed rural or suburban areas. In this video we'll go on with the entry approaches design of single lane roundabouts located in high speed environments where normally approaching speed is more than 45 miles per hour. Well, entry approaches design of modern roundabouts is a vital part, actually it's a critical design objective, and it needs really special attentions. Otherwise, single vehicle crashes like rolling over or colliding with the center island will arise. All right, let's get started. We'll start the second part, geometric design of modern roundabouts, introducing geometric elements, and the references are the same as the last one, so let's just skip them and get to the subject of this video. Alright, when you're designing entry approaches in high-speed environments, first thing you need is the speed counters. Here are the speed counters from Ashlow Green Book 7th edition, figure 2-34, and this is from NCHRP report 672. Actually, the cross-section treatment that it recommends for entry approaches in high speed environments where the approaching speed is more than 45 miles per hour. Well, as you can see, it consists of 3 consecutive reverse curve, and the mean of this cross section is to make drivers slow down step by step, almost 12 miles per hour in each step. It doesn't give any more detail except for what you can see in this figure, so I for one prefer to refer to Wisconsin guide on designing modern roundabouts, which is this table here, from which you can determine the radius of your consecutive curves. Here I'm going to demonstrate how you can use these tables to develop your entry approaches. Alright, here are the approaching speeds, and here are the speeds associated with the second curve. And unlike we just mentioned from NCHRP report 672, here the drivers are required to reduce their speeds around 25 miles per hour in each step. So for an approaching speed of 50 miles per hour, the second curve will be designed for 25 miles per hour, or for an approaching speed of 60 miles per hour, the second curve will be designed for 35 miles per hour, and so on. Suppose the approaching speed is 70 miles per hour, so the start of changing the cross section will be around 600 feet based on the speed counter in advance of yield line or crosswalk, and the second curve will be located where the speed is around 45 miles per hour. So the approaching speed is 50 miles per hour minus 25 miles per hour. The second curve will be designed for 45 miles per hour. All right, we draw this line first, which is shifted to the right. We want to use this column. This is not actually recommended for rural areas to introduce the first curve to the left, so we use this column here, the curve to the right, and it's shifted to the right around 15 feet related to the direction of the center line of approaching roadway. It's a good one to start with. It should actually be greater than the width of approaching lane or lanes to provide enough deflection for the first curve. Now, having these 2 lines and referring to this table, given the approaching speed of 70 miles per hour, the R value of the first curve should be greater than 2800 feet. These values are actually calculated based on F max associated with each approaching the speed and cross slope equals 2%. All right, we got the first curve. Let's see about the second curve. To develop the second curve, first draw this line to the left of the Sonora Island. Again, 15 feet, it's a good one to start with. You'll need to verify these values through checking the entry angle and also checking the performance of the roundabouts in the next steps. But these are actually good values to start with. Now you offset these lines to the right equals the width of approaching lane, and now referring to this table here, the approaching speed was 70 mile per hour minus 25 mile per hour. The second curve should be designed for a speed of 45 mile per hour. So our value of greater than around 1,000 feet you should use for the second curve here. These values are again calculated for F max associated with each speed here, and cross slope equals minus 2%. All right. Again, having these two lines and using these values here, you can develop the second curve. The rest are kind of the same as we discussed in the previous video. To develop the entry radius, we got the ICD. We need an offset from this line to the right equals 2 feet. Actually, this is the lateral clearances between the face of the curve and the edge of traveled way, and the R value you can pick from this range around 65 feet to 100 feet. Now pick a value from this range, which you will verify through performance check of the roundabout. You draw a curve tangential to this line and the ICD, and as we mentioned in the previous video, you need to narrow the shoulder almost 100 feet in advance of yoke line. You can do this by extending this curve beyond where it intersects with the edge of shoulder, and here you are, you got the right side of your entry. To develop the left side of entry, first you need this width here from the edge of paved shoulder to the spoiler island on the left side, and here from the curve on the right side to the spoiler island. This two widths here you can get these widths referring to table 3-27 Ashdown Green Book 7th edition, and based on your traffic condition for this portion of your entry approach, case 2 is appropriate. Here case 2, and from here for radius greater than 600 feet or tangent portion of your entry approach, which is corresponding to this portion, a width of around 17 to 20 feet is adequate, and based on your traffic condition. And for this width here, case 1 is adequate given the radius for entry around 75 to 100 feet. Normally you get a width of around 17 to 20 feet based on your traffic condition and your entry radius. You need to add 2 feet to these values that accounts for the lateral clearance between the edge of traveled way and also the face of the curve. Now you get these widths here and here, you draw this line, and to get the left side of your entry, you develop a curve tangential to this line and the edge of apron with an R value almost 20 feet greater than your entry radius. So here your left side of your entry. All right, the same as treatments that goes for approaching nose of splitter island for conventional intersections, as we discussed in the previous video, also goes for this one too, and offsetting these lines based on your width of your shoulder, and also the lateral clearance that it's almost 2 feet based between the edge of your traveled way and also the face of the curve. You can get your entry approach. All right, we're kind of done with geometric design of single lane roundabouts. In the next videos, we will discuss geometric design of multi-lane roundabouts. Thanks for giving me a part of your daytime. Hoping it was helpful. I say goodbye for now.